Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of the washer method. What is the washer method? Well, the washer method is kind of like the disk method, but our region that we're trying to find the volume of once we rotate a 2D object to make the 3D object is going to have a hole in the center. So if you were to take cross-sectional slices, then you would have a hole in the middle of whatever region. Whereas disk method, you wouldn't have a hole in the middle. Okay? Again, this will become more apparent once we do some examples. I'm just trying to get you introduced to where you don't get shivers up your spine every time you hear the words washer method. All right, so what is going on with the washer method? Well, we are going to be using the fact that our region of interest when we go from two-dimensional to three-dimensional is going to have a hole in it. Okay, so when we rotate it around an axis, instead of being a solid region, we're going to have a shape inside that's missing, like you gutted something out of it. Okay, so there is a hole. So you're going to use this formula here, where we have the integral from alpha to beta of the f of x, which we will see is the outer function, minus g of x squared, which is the inner function. So again, what are those? Well, so what are your f of x and g of x? Your f of x is your outermost function, and your g of x is the innermost function. And you literally just plug and chug. So note, again, just like in the disk method, if the rotation is around the y-axis, then these alpha and betas become, instead of x equals values of the smallest and the largest, they become y equals the smallest and the largest. This becomes f of y. And then our functions are going to be x equals some function in terms of y here instead of x. And g is also going to be in terms of y. Okay? So you might have to solve it for x equals to plug it into here. Don't forget to do that. Okay? Then integrate, plug and chug. If you're shaky on your integration, go back and set that foundation solid. Okay? But the key is always to practice, practice, practice. You will see that there will be one of these techniques that best fits each situation. And the only way to really know which one is applied when is to practice as many problems as you can. All right? Hope I've clarified any confusion you might have. As always, practice, practice, practice. Thank you, and have a nice day.